7.1, number 15. So this one is a problem that looks like this, and you might recognize almost right away that it's an integral of an exponential function times a trigonometric function. We did one of these in class in our notes in section 7.1, and it was that tricky one where we ended up solving for the unknown integral, and I think that's what's going to happen in this problem as well. So we see two distinct parts to the integrand. They don't really look related at all. We can't get one's derivative to match up with the other, so it's not a u substitution problem, so we're going to try integration by parts. According to Lippitt, we're going to let u equal the exponential function, the e to the negative x, and dv is going to be everything else, which is the sine of x dx. We differentiate u to get the opposite of e to the negative x dx, and we anti-differentiate dv to get v equals negative cosine of x. So doing that, we have here that the original integral now is going to equal u times v, which in this case is negative e to the negative x cosine of x, minus the integral of v du. Now there's two negatives to be pulled out in front there. Those end up canceling each other out. So we end up with minus the integral of e to the negative x times cosine of x dx. And I went ahead and put a set of brackets around that integral, and you'll see why in just a second. But the question at this point would be, is the new integral any easier to evaluate than the one that we started with? And the answer is no. It's really no better than the one that we began with. However, there's reason to think if we know what's coming that one more time might be good enough. So we're going to do integration by parts a second time on that new integral inside the brackets. We're again going to let u equal e to the negative x. dv in this case is cosine of x dx. We differentiate u to get the same result. We anti-differentiate dv to get that v is equal to sine of x. So now the original integral is equal to, and we have the original uv term, which was right here, and now we see repeated again right here, negative e to the negative x times cosine of x. Then we had a minus right here, and in the brackets, that's where the integral started. So that minus sign comes right down to here, and now inside this new larger set of brackets, we have our new u times v, e to the negative x times sine of x, minus the integral of v du. Now because there's a negative in front of that e to the negative x there, we'd pull that out in front, and this minus is now going to become a plus, the integral of e to the negative x times sine of x dx. And we should recognize that's the same integral as the one we began this whole process with. So if we keep going with this, we're going to distribute that negative now and get this here. Negative e to the negative x cosine of x minus e to the negative x sine of x, and a minus the integral of e to the negative x sine of x dx. But again, recognizing this now as the same integral we began with, we're going to bring it from the right side over to the left by adding this integral term to both sides, once on the right and once on the left. And we can see that these two terms right here are going to cancel each other out. These two are going to combine to make a 2 integral of e to the negative x sine of x dx equals, and here was the first uv term, negative e to the negative x cosine of x, and then minus the second uv term, minus e to the negative x sine of x. Well, that integral right there is the one we were looking for, so we just divide both sides by 2, and we get our answer. The integral of e to the negative x sine of x dx is equal to, and there's a lot of different ways we could have done this right here, but we factored out the negative e to the negative x and the 1/2 from that 2 on the bottom, and came up with a negative 1/2 e to the negative 1x times the quantity of cosine of x plus sine of x. And of course, because we were evaluating an indefinite integral, we're going to add a c at the end of all that.